Okay guys, so today what we're going to do is we're going to talk about graphing sine and cosine, and we'll just do a few transformations on the functions, but mainly we're just going to try and start with how do you graph sine and cosine. Okay, so first of all, I'm just going to go ahead and draw an x and a y, or mainly I'm only looking in the first and fourth quadrants, okay? So I'm going to start with the unit circle, and I know that at 0, let's talk about sine first, so we'll do sine of theta. At 0 radians, cosine is, or sine is 0, right? So at 0 radians, sine, because remember, x and then y, cosine and sine. Okay, so sine is 0 at 0. Okay, well then I'm going to skip to the middle. Okay, and then I know at pi over 2, so at pi over 2, sine is 1. So I'm going to go ahead and let this be 1 and plot my point. Okay, well I'm going to skip to this one, and I know that at pi, sine is back to 0. So if this is half pi, then this is going to be pi. So sine is back to 0. Okay, well then if I go to 3/2 pi, so 3/2 pi, then I know that sine is at -1. So I'm going to plot that point. And then if I go back to 2, or if I finish off at 2 pi, sine is back to 0. Okay, now the circle just keeps on going. So if I rotate again, if I go another half pi past 2 pi, then I'm back at 1, and then I'm back at 0, and then I'm back at -1, and then I'm back at 0. So what the function does is it actually repeats itself. So it looks like a wave where that right there is 1 period, because it repeats itself, so it does it again. And it would do it again and again and again. And it does this way as well if I go backwards. So if I said negative pi over 2, then it would be at -1 right there. And so we keep on doing the same thing on either side. Okay? But what you have to know is that this right here is one wave of sine. Okay? So if I say, what does sine look like? Well, then here's what I say. Sine starts at the origin, goes up, comes back down. Halfway through its period, it's back at the origin, and then it goes down, and then it comes back to the origin at the end of its period. So sine has a period of, well, it took a full 2 pi to get there, so 2 pi. And what it is, this right here, it goes up 1, and it goes down -1. Well, from the center of the graph to the height of the wave, either up above or down below, we call an amplitude. Okay, so the amplitude in this case is 1, because the wave goes up 1 and then down 1. Okay? Well then, let's talk, and I kind of filled in these points, but if you actually typed them in at 30, or at pi over 6, so if this is pi, half pi, this is pi over 4. Pi over 4 square root of 2 over 2. If I type that in, square root of 2 divided by 2 is 0.707. So you can see that at half pi, 0.707, that makes sense. If that's 1, then that's good. And then at a 6, that should be at 1/2. If this is 1, this is 1/2. And then it should be a little bit more right there. So it follows along with the pattern, okay? It follows along with these numbers, 0, 1/2, square root of 2 over 2, square root of 3 over 2, and then 1. Okay, and then it'll repeat itself. It'll just go backwards. Okay, so then there's cosine. Okay, so cosine at 0 radians is 1. So at 0, cosine is up here at 1. Well then at pi over 2, cosine is, so at pi over 2, cosine is 0. So I'm at the origin. And then at pi, cosine is at -1. So at pi, cosine is at -1. At 3/2 pi, cosine is back at 0. And then at 2 pi, cosine is back at 1. So when I end up where I started at 1, I ended at 1. That is the end of the wave, okay? So I would sketch it by drawing my wave. And then if I did another period, it would just repeat itself. So it would do this and this and this. And so there's another full wave. Oh, I gotta keep going more. Okay? So this, once you get to where you started, then you've finished a full wave. Okay? So again, the period is 2 pi. And again, the amplitude, since this is 1 and this is -1, the amplitude is 1. Okay? So then the only other thing I'm going to go through is, what if I ask you to graph it with a different amplitude, or shifting it up and down? So those are just transformations of functions. So let's go to 2 sine. Okay, so if I'm going to graph the function 2 sine, then okay, I'm going to use what I know about sine, and the fact is that sine, I know, starts at 0, goes up, comes back down, and then goes to the origin, with this being half of its period, pi, and this being 2 pi, making this half pi and this 3/2 pi. So when I'm sketching 2 sine, here's what I'm going to do. I'm going to draw a dotted line at 2, and I'm going to draw a dotted line at -2, because those are my amplitude lines, okay? So I know that I need to go up to 2 and I need to go down to -2. But sine starts at the origin, so I'm going to start at the origin. At pi, or at half pi, I need to be up at 2. At pi, I need to be back at the origin. At 3/2 pi, I need to be down here. And at 2 pi, I need to be right here. One wave is enough, so I'm just going to go ahead and sketch them together. And then there we go. Okay? So then what if they say graph 1/2 cosine? Okay, so 1/2 cosine, well, the amplitude is only 1/2, which makes it a little bit more difficult because my amplitude lines are pretty small. I can only go up 1/2 and I can only go down 1/2. Okay, so 1/2 cosine. Well, I remember that cosine starts up here, goes, and then there, and that's the end of the period, 2 pi, which makes this pi, which makes this half pi. Okay? So at the origin, I need to be at the top of the amplitude, at the top of the wave, and then at half pi, I need to be at the origin. At pi, I need to be at the minimum. Okay, so at pi, I'm at the minimum. At 3/2 pi, I'm back at the origin, and then at 2 pi, I'm back at the top of the wave. It's a very skinny wave, or very flat wave, but there we go. Okay? Okay, so what about vertical shifts? Well, all we're doing is we're shifting up or shifting down, but I haven't, if you notice, changed the amplitude on the wave. And I didn't really, I'll go ahead and say this because I didn't say it a minute ago, but I need to. A sine of bx plus c plus d, or a cosine of bx plus c plus d. What we're dealing with is A today, amplitude. And if you remember from transformations, if I multiply by a number bigger than 1, it's a vertical stretch. So I stretch the graph from what it normally is. Normally it's like this. Okay. But I stretched it by a factor of 2. And if I multiply by a number smaller than 1, I horizontally compress it. So normally it's up here, so it does this. But I horizontally compressed it, so I made it, or not vertically compressed it. So I made it a little bit wider. Not wider, but you know what I mean, condensed. Okay. So then the only other thing we're going to talk about is vertical shift. If I add on the outside, if I subtract on the outside, that means going up or down. Okay, so plus d is the vertical shift. It doesn't have to be plus, it could be minus. Bx and c we'll talk about later. Okay, so if I've got sine minus 3, then here's what I'm going to do. And this is what I want you to do. You draw on your x and your y, you go to -3, and you draw a horizontal line. That is your new midline. Okay, so that's my midline of my wave. Now sine, in this case, still has an amplitude of 1, so I'm going to draw my amplitude lines, one above and one below the midline. Okay, well now I need to sketch. Okay, so it's a sine wave. So I've taken care of this, I've taken care of that. So really I just need to now graph a sine wave. I remember that sine starts at 0 and then goes up. So at pi over 2 it should be at the top. At pi it should be back at the origin. At 3 pi over 2 it should be at the minimum. And then at 2 pi it should be back there. So then I have my sine wave shifted down 3 with an amplitude of 1. And so there we go. Okay. Same thing if I shift up 3 with cosine. Okay, I'm going to draw a midline at positive 3. So cosine plus 3. Plus 3 on the front is the same thing as cosine of theta plus 3 in the back, okay? So it doesn't really matter where the plus is, plus and minus. If it's a plus or minus, it's a vertical shift. The amplitude is still 1. So I'm going to go up 1, and I'm going to go down 1. I'm going to graph my cosine wave, okay? Cosine starts at the amplitude, the high amplitude. At pi over 2 it should be at the origin. At pi it should be back at the minimum, or at the minimum. 3 pi over 2 back at the origin, and 2 pi up at the top. And so there we go. Okay, what's not acceptable is drawing this, okay? That's not a wave, so try and create some curve in there when you're drawing those waves. Okay, so we'll just do 2 more. If I have a combined amplitude and vertical shift, well, first I take care of the vertical shift. I'm going down 1, so I'm going to draw my midline at -1. Okay, then I'm going to do my amplitude, and amplitude is 3 from the midline, so I'm going to go up 3 from the midline, 1, 2, 3, that puts me at positive 2. I'm going to go down 3 from the midline, 1, 2, 3. It's a sine wave. Sine starts at the origin, my new origin. At pi over 2 it should be at its max, at pi it should be back at the origin, at 3 pi over 2 it should be at its min, and at 2 pi it should be back at the origin. So my wave, sorry, I was kind of tilted there, it should look like this. I go up, come back down, and then go up. And there we go. Okay, so one more, 4 plus a half cosine. 4 is my vertical shift, so I'm going to go up 4. My amplitude is only a half, so I'm going to do a half. Go up a half from 4 and go down a half from 4. Okay. Cosines should start at the max and then go to the origin. So at pi over 2, at pi it should be at its min. At 3 pi over 2 it should be back at the origin. At 2 pi back at the max. And so there's my wave. Okay. If there's anything you don't understand, or if I went too fast, you can definitely rewind it or watch it again on your phone if you need to. Only if you're watching this, though. Or just work with each other on the homework. Hopefully, if you got the one wave, sine and cosine down, then you can just recreate them with vertical stretches and compressions and vertical shifts. Okay, I'll see you on Monday.